In this video, I'm going to attempt AWS Certified Advanced Networking Specialty mock exam. So let's begin. The first question is, you have an EC2 instance in a private subnet that needs to be accessible via SSH from administrative purpose. For security, you want to avoid deploying a bastion host that is open to the internet. Which service allows you to connect to the instance without requiring a bastion host, an internet gateway, or a public IP address on the instance? It's the systems session manager, AWS system manager, session manager. The explanation is analysis of the correct option D. Session manager is a fully managed AWS service that lets you manage your EC2 instance through an interactive one-click browser-based shell or through an AWS CLI. It does not require inbound ports to be open or bastion host or public IP. The instance only needs the SSM agent installed and outbound connectivity to the systems manager service endpoint. Okay, why other options are incorrect? Client VPN would provide network connectivity to the VPC, but would still need to be able to route the instance's IP, private IP, and have appropriate security groups. Option B is incorrect because EC2 instance connect requires the instance to have a public IP address to connect from the internet. Option C, an EC2 instance connect endpoint allows you to use instance connect to reach instance via private IP, but it still requires network reachability. So the correct answer is systems manager, session manager, because it is a browser-based thing that you just connect from the AWS page, and it lets you do the management of a EC2 instance. Let's go to the next question. Second question is, a Route 53 resolver forwarding rule is configured with the following settings: domain name corp.example.com, rule type forward, target IP 192.168.110, 192.168.210. Okay, an EC2 instance in an associated VPC makes the DNS query for server1.corp.example.com. What is the behavior of the Route 53 resolver? What is the behavior of the Route 53 resolver? It will return both 10 and 192.168.110 and 192.168.210 to the EC2 instance. It will forward the DNS query to both 192.168.110 and 192.168.210 simultaneously. It will choose one of the target IPs, 192.168.110, forward the query and wait for the response. If that server is unresponsive, it will then try the other target IP. It will return a NX domain error because the Route 53 does not own the corp.example.com zone. Yeah, I don't think option D is the correct answer here. I think option C is the correct answer. Yeah, that's correct. Let's see the explanation. Forwarding logic. When a forwarding rule has multiple target IPs, the Route 53 resolver does not act as a load balancer. It uses a defined algorithm to select one of the target IP addresses to forward the query to. It waits for the response from that target. If the target is unreachable or fails to respond within the time period, the resolver will mark it as unhealthy for a short time and retry the query with another IP address from the target list. This provides resiliency for the outgoing path. Why option A is invalid? It's because the resolver job is to get the final answer, not to return the IP address of the intermediate DNS server. Option B is invalid because it does not forward simultaneously. It selects one target, retries it, and then falls back to the other ones. Option D, the entire purpose of the forward rule is to tell the resolver that it does not own the zone and must ask another server for the answer. Next question, number 3. When you create an alias record in Route 53 pointing to CloudFront distribution, what are the key benefits regarding DNS queries? Option A, the queries are routed through a more direct network path. Option B, Route 53 returns the IP address of the CloudFront as node directly in the A/A record response, avoiding the CNAME lookup chain. Okay. Option C is the TTL for the query is automatically set to a very low value for faster updates. Option D, queries are automatically encrypted. No, I think the right answer is option B, because DNS query, when there is a DNS query, it returns locally, directly, CloudFront edges directly, and then avoid CNAME lookup chain. Yeah, that's the right answer. When the client resolves a CNAME record, the DNS resolver must perform a second lookup for the canonical name to get the final IP address. An alias record is the Route 53 specific virtual record. When a query for an alias record is received. Route 53 looks up the current IP address of the target resource and returns those IP directly to the client as if it were standard AA records. This is more efficient as it resolves in a single round trip from the resolver perspective. Next question, number 4. You need to prevent operators from accidentally deleting a crucial production transit gateway that is managed by a CloudFormation stack. Okay, which CloudFormation feature would you use to protect this specific resource from deletion or modification during a stack update? Deletion policy of retain. Deletion depends on attribute, stack policy, or change set. Okay, I think the right answer would be of deletion policy of retain. No, that's the wrong answer, or stack policy is the right answer. Let's see why is it right. The stack policy is an IAM like JSON policy document that you attach to the stack itself. It governs which update actions like replace, delete, or modify are allowed on which logical resources within the stack. To protect the transit gateway, you would create a stack policy with a statement that has effect, deny, action, update, and resource the transit gateway. With this policy in place, any attempt to update or delete the stack in a way that would affect the TWG target gateway will fail unless a temporary overriding stack policy is provided with the update command. Alright, next question, question number 5. What is the purpose of nested stack in AWS configuration? Nested stack in AWS configuration. To deploy a stack across multiple AWS accounts. Option B is to create a stack within another stack, allowing for the reuse of common templates and composition of complex architectures. I think this is the right answer. C is to create a backup of stack's configuration. Option D is to prevent the change that will be made during the stack update. Option B is the right answer, modularity and reuse. A nested stack is a stack created as part of another parent stack. You can define a common template for a piece of infrastructure, example the standard application server configuration, and then use the AWS CloudFormation stack resource to create instances of the nested stack from within your parent stack. This promotes reuse, consistency, and helps break down a large monolithic template into smaller, more manageable pieces. Question number 6. Why are you using Amazon Athena to query VPC flow logs stored in an S3 bucket? The logs are partitioned by date. How does partitioning the data benefit your queries? Okay, you're trying to do a query on VPC flow logs, which is in the S3 bucket. It's partitioned by date. How does partitioning the data benefit your queries? Alright, it encrypts the log data automatically. Option 1 is, I don't think that's correct. Option B is it reduces the amount of data that Athena needs to scan for queries that include a date range in the where clause, which improves performance and reduces query cost. I think that's the right answer. It converts the log data from JSON to Parquet format. Not sure about that. Option D is it allows multiple users to query the same data set concurrently. I think the right answer is number B. It reduces the size the software has to scan. That's correct. Partitioning, pruning. When you partition your data in S3, whatever data it is, you can define these partitions in your Athena table metadata. When you then run a query with the where clause with filters on the partition key, Athena query engine is smart enough to only scan the data in the S3 prefixes that matches the filter. This is called partitioning pruning. It dramatically reduces the amount of data scanned, which directly leads to faster query performance and lower cost, as Athena charges based on the amount of data scanned. Okay. Which segment is true regarding data processing charges for traffic passing through AWS Transit Gateway? Data processing charges for traffic passing through AWS Transit Gateway. There is no data processing charges for a Transit Gateway. Option 1. Option 2 is you are charged a per gigabyte data processing fee for all traffic that passes through the Transit Gateway, regardless of the source of or destination availability zone, AZ. Option C is you are charged a per gigabyte data processing fee, but traffic that stays within the same availability zone is processed for free. Data processing charges only apply to traffic that is routed to an on-premises network via a VPN or direct connect attachment. I'm going with option D. Let's see if it is correct or not. No, it's not correct. The correct option is option C. You are charged per gigabyte data processing fee, but traffic that stays within the same availability zone is processed for free. Okay, good to know. TGW same AZ optimization. The AWS Transit Gateway pricing includes per gigabyte data processing fee. However, a key cost optimization feature is that if the source and destination of the traffic and two EC2 instances are in the same availability zone, there is no data processing charge for the traffic passing through the transit gateway. This incentivizes designating applications within AG affinity to reduce cost, similar to reducing the standard cross AG data transfer cost. Alright. Question number 8. When implementing a centralized ingress traffic ingestion pattern, where traffic from the internet is inspected before being sent to an application VPC, what is the common architecture? What is the common architecture? Option 1, route traffic from the internet gateway directly to an application VPC, where the local AWS network firewall inspects it. Alright. Option 2 is route traffic from the internet gateway to an external application load balancer, which forwards to a gateway load balancer and a fleet of firewalls, which then routes to the internal application load balancers. Wow, that's a complex architecture. Option C is route traffic from the internet gateway in an ingress VPC to a transit gateway, which then routes to a fleet of firewalls and finally to the application VPC. Use AWS Global Accelerator to route traffic directly to the application instances bypassing any firewalls. I don't think that's the right answer. Not our internet gateway directly to the application VPC, where the AWS local network firewall inspects it. Okay, I'm going with option A, but I don't think this is the right answer. Let's see. The right answer is option C, route traffic from the internet gateway in an ingress VPC to a transit gateway, which then routes to a fleet of firewalls and finally to the application VPC. So it's basically from the all the internet traffic comes to the internet gateway. So from there, routed to the transit gateway, ingress or custom VPC or ingress VPC to a transit gateway, and from transit gateway to the set of firewalls, and then to the application VPC. Okay, good to know. A common pattern involves an ingress VPC which contains an internet gateway and a public facing load balancer. Traffic hits the internet gateway and is routed to the transit gateway attached in the same ingress VPC. The transit gateway then routes this traffic to an inspection VPC containing the firewall fleet. After inspection, the traffic is sent back to the target transit gateway. Transit gateway then performs a final route lookup and sends the traffic to the correct application VPC. This provides a scalable way to inspect all inbound traffic before it reaches any application. An alternative, simpler pattern is described in option B, but C is also a valid target transit gateway to best aggressor, given the option C is well defined pattern using transit gateway. Alright. Next question, question number 9. An AWS network firewall has stateless rule group as its first rule group. The default action for this stateless group is forward to SFE. Okay. The group contains one custom rule with priority 100 that drops all TCP traffic. What will happen to an incoming UDP packet? Incoming UDP packet. It will be dropped by the TCP rule. I think this is the right answer. Option 1 is it will be the traffic will be dropped by the TCP rule. Option 2 is it will be passed to the stateful rule engine for further inspection. Option 3 is it will be dropped because it doesn't match the TCP rule. Option 4, it will be allowed and immediately passed to its destination. I think the rules are evaluated based on the number of priority. So 100 is the lowest priority, I guess, so it will drop. No, it doesn't. It will be passed to a stateful rule engine for further inspection. Okay, let's see. So incoming UDP, is it the UDP packet? What will happen? Drop all TCP traffic, okay. Incoming UDP packet, okay, it's a UDP packet, so it will not be dropped because TCP packet has been dropped. Sorry, I didn't read the answer or the question correctly. The incoming UDP packet is fastest evaluated against the stateless rule group. It's checked against the custom rule at priority 100. This rule is the TCP traffic, so the UDP packet doesn't match since it doesn't match any specific rule in that group. The default action for the group is taken. The default action is forward to SFE, forward to stateful engine. Therefore, the UDP packet is passed on to the stateful rule. engine for next inspection. Okay, next question number 10. To inspect TLS SLS traffic with AWS Network Firewall, what must be configured? To inspect TLS or SLS traffic with AWS Network Firewall, what must be configured? Option 1, firewall must be placed behind an application load balancer that performs TLS termination. You must import your server's private SSL TLS key into the network firewall configuration. The firewall's stateful engine can perform TLS inspection by intercepting the traffic and acting as a man in the middle, re-encrypting with its own certificate. The firewall's stateful engine can perform TLS inspection. This is not possible. Network firewall cannot inspect encrypted traffic. I think option C is the correct answer here. That's correct. TLS inspection configuration. To inspect the contents of encrypted traffic, the network firewall must be able to decrypt it. It does this through TLS inspection configuration. You provide the firewall with a certificate authority certificate. The firewall then intercepts the TLS handshake, presents a certificate to the client that is signed by CA, and establishes the TLS session with the client. It then establishes separate TLS session with the actual destination server. This man in the middle position allows it to decrypt, inspect, and then re-encrypt the traffic. For this work, the client connecting must trust the firewall CA certificate. Alright, it has to do that. Okay, so the exam is complete. I got 60% marks. Let's review the questions that I got wrong. So question number 4 is what I got wrong. You need to prevent operators from accidentally deleting a crucial production transit gateway that is managed by a CloudFormation stack. So the right way is to create a policy, stack policy, and attach the stack policy to the stack that will prevent it from being updated or deleted when somebody is deploying another stack in the CloudFormation or any other way. So the second question that I got wrong was, which statement is true regarding data processing charges for traffic passing through AWS Transit Gateway? So the correct answer is that traffic passing through Transit Gateway within the same availability zone will not be charged, but to different availability zones will be charged per gigabyte. Next question is, when implementing a centralized ingress traffic inspection pattern, what is common architecture? The common architecture is separate the VPC or the network completely. So the traffic will first come to an ingress VPC where it will be routed through a transit gateway to a second VPC where it will go through a bunch of firewalls, and if the traffic is good, it will then route to the final application VPC. Next question is, AWS Network Firewall has stateless rule group. So it has a rule group where it's forwarding the traffic to stateful rule engine, and then there is a second rule with priority 100, which is like the highest priority, which drops all the TCP traffic. The question is, what will happen to an incoming UDP traffic? So the rule 100 will be evaluated first, but it only dropping the TCP traffic, and since this is a UDP traffic, doesn't match the rule. It doesn't match the rule, so it will go to the first rule, and which is basically transferring it to the rules engine. So that's it for today. See you guys next time. Bye.